Hi, it's Paul Browning here. Welcome to the CCNA in 60 Days training course. The book's version 4 if you want to get it on Amazon. If you could like the video and subscribe to the channel and hit the bell, you'll see all the other videos. So in 60 days, EIGRP day 22. All I can say is EIGRP has been taken out of the syllabus. So it was in before the current version and before that and before that. You still need to know it. I put it back in because I sat the exam. So that's all I can say. I can't say anything else because of the non-disclosure agreement you sign when you take the exam. So that's all I'm going to say, but you do need to know it. Every day read the cram guide, watch the videos from the day before also, and do the labs from the day before. Take the online exam, link on day 0 and day 1. EIGRP, there's about 3 labs to do. There's some books that will help you. They're all on Amazon, version 4 for the CCNA Labs book. Now without further ado, we'll get into the lesson. EIGRP. Again, this was another subject that was fairly straightforward for the old style CCNA. Cisco have really sort of ramped things up now for EIGRP, so you've got to dig more into the guts of how the protocol works. But transversely, really, you only need to be able to do a basic configuration. So we're going to be doing some labs on the EIGRP anyway. But it's another subject similar to OSPF where you could actually go into a great amount of detail. Our CCNP guides, I think OSPF is around 150 pages of the book, which is a sizable chunk. EIGRP is maybe 100 or so. So we're going to cover some of the basics, stuff you need to know for the CCNA exam, the new style exam. So let's get cracking on. So Cisco developed EIGRP, so it's considered proprietary. It uses distance vector elements, and one of them is split horizon, but it also uses link state elements, such as incremental updates. So it can be considered a hybrid protocol. It runs over IP using protocol 88. Now, we used to cover RIP version 2 and IGRP in the CCNA, but they've been phased out. So you can't actually compare the two from your studies unless you actually look at some in your own time. But EIGRP was designed to overcome some of the limitations of an older protocol called Interior Gateway Routing Protocol. Firstly, the hop limitation, full routing table updates made it a very bandwidth intensive and chatty protocol. It didn't support VLSM and it was very slow to converge. But then again, you've got to bear in mind that when IGRP was designed, networks were very, very much smaller than they are nowadays. Also, a lack of loop prevention caused problems. EIGRP sends updates when the topology changes. Default hop count of 100 devices, but you can tune that to 255 as a maximum. It does support variable length subnet masking. And at the core of EIGRP is a diffusing update algorithm known as Dual, and this is used for loop prevention. Configuring the EIGRP is it's actually very user friendly. Your command is router EIGRP and then the autonomous system number, which is any number you care to choose. However, it must match on every router in your EIGRP domain if you want them to form a neighborship relationship. Your values are anything from 1 to 65535. If you show IP protocols, you'll see routing protocol is the EIGRP and the ASN here is 150. Adding networks, very simple. Add the major networks to include all subnets. If I wanted all of these networks, if they were attached to my router, say for example I was doing a test and these are all in the loopbacks, I would issue the command router EIGRP and then the autonomous system number, which in this instance is 20, and if I type network 0.0.0.0, it would actually add all of these networks for me. The problem is, or there could be a problem in that it would summarize all these networks. By default, you can see above maximum pass for it says automatic network summarization is in effect. Now, you may or may not want this to actually happen, just depending on how the addressing is set in your network and what you want to achieve. The EIGRP topology table, which I'll go into the outputs shortly, shows you the topology that you're running for your EIGRP process. And here's the networks I mentioned here. I've actually put them all in my loop bags just for testing. Do you need to know these outputs? If you look on the last presentation, you can see all these outputs here are shown in a passive mode, which is actually what you want. There's no computations taking place at the moment on these routes. So just in case, I recommend you pause this part of the video and make a note of what the possible topology field outputs are, just in case. Specific subnets. Now, if you've got, you saw the problem we had, or potential problem you had in the EIGRP, was advertising all of the attached 10 networks, which is what it's designed to do. So instead of that, what you could do if you wanted to advertise specific networks is configure EIGRP, the ASN number, and then add the specific networks with a wildcard mask. And then what will happen is EIGRP, sorry, I've just been recording OSPF, EIGRP will then advertise those specific networks. So that gives you tighter control of which networks are advertised. And for whatever reason on your network, you may not want certain networks to be advertised within your routing domain for whatever reason. So this gives you a lot more control. So you can see the wildcard masks have been added there, and we discussed wildcard masks in the access list section. So auto summary. EIGRP is designed to automatically summarize routes. It does it on all major network boundaries. So if you've got a 10 network, it will advertise it as a /8 network on any major network boundary. Now that's actually been changed as default behavior from iOS 12.4 onwards. So auto summary is turned off. If you need to manually turn it off with an earlier iOS than this, the command is simply no auto-summary. So I just want to illustrate the point here. We've got a network here, two routers. A network between the two routers is 192.168.1.0. I've got a loopback off the left-hand router, router 0, which is 10.2.2.1/24 and 10.1.1.1/24. Now, you can see router 0 here. If I type ping 10.1.1.1, the ping has actually dropped. And when you examine the routing table, you can see why. EIGRP knows it's got a connected network, and it's put connected network 10.2.2.0. The default behavior with auto summary then is to place all of the traffic that's no more specific than 10.2.2.0 into an interface called null 0, which basically means it goes in the bin. So any traffic for any other network that isn't in this table here, i.e. not connected, will be dropped. So I've done a show IP route this time, and what I did on router 1 is I added the no auto-summary command. So now router 1 is actually advertising its 10.1.1.0 network across to router 0. You can see the 10.1.1.0 network is now shown as an EIGRP network with designated by the D, and it's saying interface to reach it is fast Ethernet 0/0, and it's learned via 192.168.1.2. And if I ping this network 10.1.1.0, then it will go to that particular network. And still, any non-specific 10 network would still go to null 0. EIGRP metric. Unfortunately, they've added this to the CCNA. I hope they don't expect you to know this, but K values are used to distribute weights to path aspects. The k values are k1 equals k3 equals 1 and k2 equals k4 equals k5 equals 0. So basically the values k2, k4 and k5 aren't used. You could configure these particular parameters, but this is beyond our scope of our syllabus. So the default EIGRP metric is 10 to the power 7 divided by the least bandwidth on the path plus the sum of all delays times 256. So I certainly don't think they'll be expecting you to work out any metrics in the exam. But I've just taken an extract from our CCNP book, which maybe you could just pause the video for a moment and just read what I've put here rather than me reading it off to you. Dynamic neighbour discovery. It's performed by sending EIGRP hello packets to the destination multicast group 224.0.0.10. As soon as you add the network command when you're using router, when you configure EIGRP on the router, this is what happens. And you can see hello sent out, hello and update back from router 2. All hellos need to be acknowledged and update packets. In fact, all packets on EIGRP need an acknowledgement. We've got a sample network here, and if I issue a show IP route, you can see to get to the network off router 1, the 172.16.100 network, you can see there's two paths to get it, obviously from router 2. Now, because the metric is exactly the same, because the links both have the same bandwidth, what's happening is EIGRP is going to load balance across the two links. You can see if you look at the output there, minimum bandwidth is 1544 and the same for the network further down. Route metric also matches. So the asterisk next to the 150.1.1.1 route is indicating that the next packet will be sent out to this route, and it's load balanced. If a packet is sent out from that route, then the asterisk will be in the above route, the 150.2.2.1, because it's load balancing across those two interfaces. Now, you could adjust the bandwidth on either interface, and that will directly affect the EIGRP metric calculation. So what I've done here is on router 2, I've configured a lower metric, a lower bandwidth, which is poor route compared to the interface serial 0/0, and pressed exit, and we can see now how this is going to affect our computations. Now you can see we've only got one route to the 172.16.100 network, and it's going via serial 0/0. Now the other route will still be held, but it will be held not in the routing table but the EIGRP topology table, just in case this more preferred route goes down for whatever reason. The EIGRP neighbour table is used to maintain state information, the address and the interface to reach this neighbour recorded. And it's used by the reliable transport protocol, which I'll go into in a moment, but this is used by EIGRP for all updates and all queries. And here's a show IP EIGRP neighbours command, which shows you the neighbour table. Diffusing update algorithm runs at the core of EIGRP. It looks at all the routes from neighbour routers, compares them, and then selects the lowest metric, which obviously, as we've seen so far, by default is the bandwidth. The whole point behind this, as with any protocol really, is to ensure a loop-free path to the destination network. The best path is known as the feasible distance. So this results in the successor route. Feasible distance includes both the metric of a network and the cost to reach it. So if a network tells me it costs 20 to get there, and for me to reach the router that's telling me is 5, it costs 5, then the distance will be 25. So just looking at this output here, we've got, if you look at the paths between router 1, 2 and 5, router 1's neighbour is router 2. Router 2 is telling me that it costs 30 to get to router 5, and then obviously you have to add then the cost from router 1 to get to router 2, which in this example is 35. From router 5's reporting 10 cost, and to get to router 3 is 20. And then it looks like the best route is advertised, the best distance or cost is coming from router 5, which is 15, and it costs 10 to get to router 4, which is advertising that cost. So from all this information, we can deduce the following. The best route, which is the lowest cost, is going to go into the routing table, which is the route from router 1 to router 4 to router 5, or vice versa. The second best route will go into the topology table, so just in case the best route fails for whatever reason. And again, the second best route will also go into the topology table. So we can consider the best route to be the successor route. The second best route is the feasible successor route. And the third best route just doesn't have a name really. I've put not, it's not a feasible successor, not at the moment. But if the main route went down, then the values would slide down. So the successor would be the second best route, as we see it on the table, and the feasible would be the third best route. Now, in order for a route, I'm just going to the top right in gold now. In order for a route to be a feasible successor, in this example, the reported distance must be less than 25. So the point of all of this is to stop any routing loops happening on our network. Okay, load balancing, also another subject on the CCNA syllabus now. By default, EIGRP will balance traffic over 4 paths. So 4 equal cost paths, that is, as we've seen in previous slides. There is a maximum of 6. If you issue a show IP protocols, you'll see maximum path indicated as 4. If you want to change that value, you just type the router EIGRP AS number and then the maximum dash paths value, and whichever one you choose. So worth remembering that command. Unequal paths, and again this is in the syllabus now, you can use a variance multiplier, which can be a little bit tricky to work out, but the value is an integer between 1 and 128. You can see the default here, EIGRP maximum metric variance as 1 by default, so it's not adding any variance. If you added the value of 5 as a variance, you're telling the router to load share across another route where the metric is 5 times worse than the minimum metric. So let's look at an example, just in case you're asked. We've got 2 routes. The 150.1.1.0 is 1024 kilobits per second, and the next route down, for whatever reason, is 768. Now, if you issue a show IP route, obviously, as we've said before, it's only going to show you the better route in the routing table. It's not got any variance added. Now you can see if I issue the show IP EIG topology to show the topology table, you'll see the metric values. The lesser route has got a higher value cost. So what we want to do is take these two numbers, and then we need to work out what variance we need. So I've divided the if you take the greater value divided by the lesser value, it works out as 1.28. In the exam, you're not allowed a calculator, and I certainly hope they won't be asking you to do any computations like this, because it would just take too long. But they may ask you some question in a simpler version of this. So the value has to be rounded up because you can't use decimal places on the variance. So in this example, it would be the value of 2. So you'd issue the router EIGRP ASN number and then variance 2, and then that's telling the router to permit this permit the worst cost route. So now if you issue the show IP route, you can actually see both have been put into the routing table, and there's a traffic share. For every 47 packets on the 150.2.2 network, 60 will go on the 50.1.1 network, because that's still got higher bandwidth, so it's doing a proportional share. I've mentioned reliable transport protocol earlier. The whole point of RTP is to ensure reliable packet delivery across your EIGRP network. It uses update and query and reply packets. Every packet sent must have an acknowledgement. Now, on non-broadcast networks such as Frame Relay, it uses Reliable Transport Protocol uses multicasts. Passive interface, another exam topic. Hellos are sent out of all active interfaces. If you've got, for whatever reason, a lot of loopbacks that don't have any networks attached, which you could be doing as part of a test before you install, or for whatever other reason you don't want updates to go out, then you have to configure these interfaces as passive interfaces. You do that in the config router mode for EIGRP, and it's passive dash interface and then the interface name and number. Now, if you've got a large amount of interfaces, sorry, I'll just show the output of the EIGRP interfaces there, and you can see only the serials active. If you've got a large amount of interfaces that you want to be passive, then you just issue the passive dash interface default command, and then whichever interfaces you don't want to be passive, you can type no passive dash interface and then the serial number. EIGRP router ID again is a new subject that's come into the syllabus. It's not the same as the OSPF, which is used to identify your neighbour. It's used simply to prevent routing loops within EIGRP, and it identifies a route that's originated for external routes. So if you see an external route come in and it's tagged with your own ID, then you know it came from your own router. The EIGRP router ID comes from the highest IP address or loopback address if present. I've issued a show IP EIGRP topology. Well worth remembering that command because that's what shows you the EIGRP router ID. I've then underneath I've configured the command EIGRP router-ID and then the IP address, and then you can see the router ID has changed to all the ones from 10.3.3.1. Just worth bearing in mind you can't use two values for the router ID as above. And if you issue a show IP EIGRP topology for a network, and this is just an example, you can see the ID of the router that originated that route. If there's a problem with the EIGRP and neighbours aren't forming, it can be mismatched K values. They have to match on both sides in order for a neighbourship to form. It wouldn't make sense that your one side of your link was one speed and the other was another speed on point to point. The ASN numbers don't agree is a classic way they catch you out. If passwords are used, they have to agree. Neighbour must be on a common subnet also, and that would be a configuration issue. Welcome to our EIGRP lab on GNS3. You can see a simple network of 192 between router 1 and 2, and I've got 3 networks of loopback addresses on router 2. I just wanted to demonstrate how to advertise specific networks off a particular router. So pretty simple configuration to start with. Obviously I'm just going to pop an IP address onto the fast Ethernet interface on both sides. Quite easy to make mistakes actually, because you get a bit blasé about adding IP addresses and then often can in your haste repeat the same IP address on both sides, or put the wrong subnet mask in or the wrong network address, and then nothing else works. So it's often quite handy to ping across the network. You can see I added the 192 network there under router EIGRP number 10 as the autonomous system number. So obviously I'm going to have the same ASN on the other side. Otherwise, we're not going to have any neighbour relationships form. So I've now shut the other side on router 2, and you can see the links come up. I've typed the do ping. You can use the do command when you're in a configuration mode to execute a command rather than coming all the way out. 80% success because the first packet dropped due to an ARP lookup. Now I'm going to add the interfaces of the networks to 3 loopback interfaces. 10-10-10 network with a /24 mask, a 10-20-20 network, and a 10-30-30. I'm just going to illustrate what happens when the auto summary is left on, when it's turned off, and then how to advertise specific networks. So there's the last IP address added for our network on our loopback number 2. Add the router EIGRP process to the networks. You've always got to add your connected network, otherwise the routing protocol won't work. I'm just going to add the 10 network, so that covers all the loopback interfaces to start with. And then on router 1, show IP route, and you'll see, as you would expect, all the 10 networks have been auto summarized to a /8. Router EIGRP 10, and I'm going to issue the no auto summary command. As you know, in later iOSs, this is actually turned on by default. Router 1, show IP route, and you should see all of the 10 networks individually displayed here. And then next, what I want to do is just advertise 2 specific networks for whatever reason from router 2. I want to keep one of my networks a secret, so it won't be advertised. So no network 10.0.000. And then I'm going to add the networks with the wildcard masks. So I'll advertise the 10-20-20 network and the wildcard mask. You can actually put the subnet mask in, and EIGRP is clever enough to invert it for you. Advertise the 30 network also. Come out of that, and then all things being equal, on router 1 we should just see those 2 10 networks advertised. And there you go, the 2 networks are showing, and that's the end of the lab. I thought we'd have a little bit of fun practicing out the variance command. You can see the network here, 150 and all the 2s and 150 all the 1s. A loopback network on router 1, and we're running EIGRP 10. Now I'm running this on GNS3, so I'm just going to use the 2 fast Ethernet connections here. You'll have slightly different outputs if you're using a home lab or packet tracer or something else. Going to run through the configuration commands, which I'm pretty sure you'll be familiar with already, so I won't do a commentary over these. On our fast Ethernet interface, we can see the bandwidth is actually 10,000 kilobits per second. So what we're going to do is change the bandwidth as if we had two lower connections. We're going to do this on our fast Ethernet 0/1 on both routers 1 and 2. So basically that means one of our connections is running at half the speed of the other connection. I'm going to check the routing table now. This command might not work in the router in the exam because you're using a router simulator, which doesn't give you a lot of choices really, so you may just have to issue the show IP route command. Hopefully it would, if they're asking you to do variance, thinking about it, because you do need to see the metric in detail. So you can see we've got a route to the 172 network and it's going on the 150.1.1.1. You can see the route in the routing table for the 172 network. Just make a change now, it'll help if you've got the no auto summary turned on. It's turned off by default on this version of iOS that I'm using. Okay, issue show IP route so we can see the correct subnet mask for our network. Show IP route for that specific network now. And it's showing correctly at /24, so it's something I missed off initially when I was configuring. Show IP EIGRP Topology for that particular network. And here we can see we've got two routes to that network. Obviously one has only one has been put in our routing table, but we have two routes. So we can load balance over these routes if we use the variance command. All we need to do is take the first value from our metric, divide the larger value with the smaller value. The smaller value will be the successor route. And that will give us our variance. Now you're not allowed a calculator in the exam, so hopefully they'll give you some simple values to work out. At the moment I'm dividing the feasible successor route, the larger route metric. I actually missed off the last zero. So I'm going to put 665,600 divided by 409,600. And that will give me the variance, and I just need to round it up then. Okay, so 1.625, so I'm going to have to round that up to 2 because you can't put that in as a variance value. Router EIGRP 10, variance 2. That's all there is to it really. Then we can check to see if this has made a difference. Just hit the up arrow to find that previous command. We show IP route, and you can see we're load balancing. We've got two routes to the same network, and an asterisk designates the next route that it's going to take. Traffic shares 37 packets, sent out to 60 packets on the other link. Just wanted to run through a troubleshooting scenario. This is our network topology here. You can see we've got a 172 network on the Ethernet connecting 3 different routers, 1, 2 and 3, and each has got a different 10 network running behind it. So just bear in mind, or have in the back of your mind, some of the problems with EIGRP and summarization when you've got a major network boundary between networks and what the default behavior is. And you can see the ways they will try and catch you out in the exam already. So just going to run through the routers. I'm going to start off with the show IP route to see if there's any routes in the table. So there's no routes on this particular router. So I tend to start on layer 1, check the interfaces. Now generally you won't have unplugged cables in the exam. You could have missing clock rates if it's a serial. And you can see we've got a administratively down interface for our fast Ethernet. So immediately you can see we have a problem here that needs to be fixed because that router can't send in hellos if it's down. So a very simple fix, no shut. You can see we've got an EIGRP notification here, so this is good news. It means it's found a neighbour and it's formed an adjacency. Show IP protocols, I want to make sure everything's working correctly. EIGRP 30 and it's routing and we can see which networks we're routing for. Show IP route EIGRP and we can see there's a 10 network there, but it's been summarized. So we're going to turn on no auto summary. Show IP route EIGRP for router 2, and you can see that's also summarizing its attached network. Check IP connectivity to router 1, so that's working fine. So I've already proved off layer 1 and layer 2 here. Show IP protocols again. We've got an issue here, you see, because it's EIGRP 40, so it's another way they can catch you out. You could quickly skip past that number and say, well, okay, we're advertising the correct networks and move on to another part of the network, not realizing that you don't have a common AS number, so you're not going to get a neighbor relationship form on this router. So no router EIGRP 40 wipes that off, and then we'll just do a standard EIGRP configuration for our attached networks. You can see we've got a neighbor adjacency information. I left off the no auto summary command there for the moment. Router 3, we can see we've got the 10.30 network showing, so we appear to be missing. We should have a 10.20 and a 10.10 showing. And this is the last issue really we need to address, the auto summarization, because our 10 network is split by the 172 network. So by default, EIGRP will auto summarize. Now, if you have the very latest iOS, that behavior may have changed. So just check with the show IP protocols. The last thing we need to fix, by the looks of it, to get the network working is the auto summary. EIGRP 30 is correct. It's automatically summarizing though, so that we want to disable this behavior. Quite easily done with the no auto dash summary, or no auto for short. And I'm going to do the same command finally on router 2. All things being equal now, we should see the full routes in our routing table. Show IP route, we can see the 10.10, the 10.30. Obviously our 10.20 is connected to this router, so we won't see that, and we can ping. So we've proved off all of the issues on the lab.